Okay, in this video we're going to look at the questions of 2019 that were poorly done, and I'm going to work you through them. The percentage on next to the question tells you the percentage that got it correct in the state. So I tried to do low ones. Alright, so looking at this question 9, when the numbers in this equation are correctly round to 3 significant figures, the equation will be. So when we're rounding to 3 significant figures, we start counting as soon as we have a non-zero. So 4 is a non-zero number, 2, and so I go to the 9. Now, once I get to the third number, I then have to look at the fourth to see if I round. Now, because that's an 8, I round up, and because the 9, rounding 9 up would make it go to 3. So I actually have to have 43.0 there for 3 significant figures. In the next one, I start counting as soon as I get the non-zero, which is here, 8, 7, 7. And looking at the fourth one there, is a 4, so I don't need to round up. So that one would be 0.877. Okay, so if we go down and we pick that answer, we would get E. Okay, in this question 10, which is probably the one I want to look at more because only 41% of the state got it correct, it says the coefficient of determination was calculated to be 0.87. So I always like to put above it that it's r squared. So they gave me the r squared. Now they want me to find the correlation coefficient, which is the r value. So when we do the square root, we have to remember it was always plus or minus, and you have to decide which one it is for the plus or minus. And the way you do the way you do decide whether it's plus or minus is you either have to look at a few things. You either look at the graph and you can see which way the dots are going. So if they're going in a downward, you know that it's a negative. Or you can look at the formula which they have given us up here, and we can see that the gradient is a negative. So that b value is a negative, so we have a negative b value, which would mean we have a negative thing. So when you find the square root of that number, you're going to get negative, so you get negative 9.45. Okay, a study was conducted to investigate the effects of drinking coffee on sleep. So when we see the effect of drinking coffee on sleep, sleep is what they're investigating, or they want to see what's happening. So when that happens, that is generally your response variable, and it makes coffee the explanatory variable. So if we talk in terms of X and Y, they would look like this. So they give us a few summary statistics. So it might be a good idea to write next to them what they are. So because it says the mean, now I know sleep is Y, so I might just write mean of Y and then mean of X. Standard deviation of Y and standard deviation of X, and the R value. So hopefully that triggered you that you would be using these formulas, which are other ways of finding A and B value using them. Now, when we see this word, on average for each additional cup of coffee, the amount of sleep, this is, when they say the wording on average, that is another way to say the gradient, and in our case, the B value. So they want me to find the B value. So I'm going to use this formula here. So I'm going to say B equals R, which they've given me, 770 times SY, which is 1.12, over SX, which is 1.56. And I get the answer, I'll get negative 0.55, which means decreased. So there. So you really need to be careful and decide what's your response variable and what's your explanatory, because you can see they've flipped them around the other way. We normally see X written first and Y second. The table below shows the values of two variables X and Y, and the associated scatter plot is shown. The explanatory variable is X, okay? So they've now told me the scatter plot is nonlinear, so hopefully that's triggering you that you will be doing a transformation. And there they said this transformation is applied to the x variable. Once again, I write what that is, just so I visually know what I've got to do. Now they want the equation of the least squares regression line. So that would be, when we write it out, we want a plus b, but it's going to be x squared now because we're actually transforming it. So the way we do that is we type our x list and our y list into our calculator. We then have to create a squared x list. So this is my x squared list. I just called it SX, and remember we pop in the equals, we can say it equals that variable squared, and I've got it. Then I've gone and done the menu and got the linreg up and a plus bx, and made sure that my x list, I picked the squared x, and my y list, I just picked my normal y. And I get my values, and we've got there, so you can see it rounds to this one. So this one, A has got the same values, but doesn't have the squared, so be careful. If you're checking your work, just sometimes when you go back, maybe to have a think about why the other answers aren't correct, that can help you pick up mistakes. Okay, so here we've got a number of days and the times that this girl Liv has run, 9 days. It says both 3 median and 5 median smoothing are considered for this data. Both of these methods result in the same value for on the day of what. So we normally do 3 median and 5 median smoothing on the graph. So I'm going to do the 3 in purple to practice that, and I'll do the 5 in another colour. So what we would do is we take the first 3 dots, and if you used a ruler and you were moving from the bottom up, it's going to be on the second highest spot. So if you look here, this purple one there is on, but I have to put it in line with the number 2 day. Okay, so sorry, out of those 3 days, that is going to be the median. All right, so then we can rub out and we can do the next 3 days, which is 1, 2, 3. So up I go with my ruler, 1, 2, and it'll be in line with that one there that I've just hit. So I'll put a cross on there, and then obviously I'm just rubbing out the dots, and I put a dot on the next one, next 3. So up I go, 1, 2, and it'll be in line with that one, and so on, and keep going. Rubbing out that one, and it'll be the next, the next 3 dots, 1, 2, it'll be in line with that one, like that, and let's go, rubbing that one out, and our next 3 dots, 1, 2, so in line with there, and then we've got, it's now getting close to our second last one, so 1, 2, so it'll be in line with that, this one here, there, and then the last 3 will actually be on that dot there. So that's the 3 median smoothing. So then when we go to do the 5 median smoothing, I'll do it in green, but what I might do is I'll show you how we could just use the table if we wanted to. So with the 5 mean smoothing, I take all these first 5 numbers, and remember it'll be marked on the 3rd day because it's the middle. So I'll be marking my first one on here. Now out of these 5 numbers, I want the 3rd highest. So you can see there's the lowest, 1, 2, 3. So on day 3, I'm going to pop it at, it'll be on the 28 one, which was actually the 3rd day anyway, like that. So you could do that like that and keep going, but I think it's much easier if I go back to the on the graph. So I'm going to do that again. So we're going to take 5 dots into account, 1, 2, 3, 1, 2, 3, 4, 5, and I'm going up this line, but I want the 3rd highest. So 1, 2, 3. So I'm actually in line with this one. So I'll just put a little dot there. There we go. And then I'm going to do the next 5. So I'm going to rub that off. And we're going to do the next 5. 1, 2, 3, 4. This one will be included. Then I go up again. I'm looking for the third. So 1, 2, 3. So it's going to be in line with this one. So about there. And then I will rub out that and put my next dot on this one. So up I go. I'm looking for the third one. 1. And I'm going along here. So I'm going up for the third. 1, 2, 3. So it looks like, 1, 2, 3, in line with this. And then the last one, the last set of 5 that I can do is the last 5, because when you do 5 median smoothing, you lose the first 2 and the last 2. So up I go. So I'm going up on day 7, 1, 2, 3, and you can actually see it's on line with the same as the 3-day. So it was day 7, the last one there. Okay, so this one says the time series plot shows the monthly rainfall at a weather station for each month in 2017. So they've asked for the median monthly rainfall for the 2017. So it's, once again, they're still doing the median, and you can do it like the median smoothing. If you had 1 to 12 numbers, the median would occur between the 6th and the 7th. Okay, so I could start down the bottom of this whole 12, and I'm just going to count up until I get to the 6th and the 7th one and look in between. So if you go up, this is the first one I hit. So I'm going to put it with a blue. 1, then I've got 2, 3, 4, 5, 6, and 7. Oh, sorry. And 7. So these are actually the 6th and the 7th one. So if you have a look, this one is on 100, so roughly 100, and this one is on 110. So it would be in between there, and you can see the only one that's in between there is that. So you can do that technique for that one. Obviously this is another poorly done one, only 37%, so you've got a lot of median smoothing in this exam. So I probably, and it was still poorly done, so expect to do it 2020. Okay, consider the following amortization table for the reducing balance loan. Okay, the annual interest rate for this loan is 3.6. So they've given you R, or on our finance solver, they've given us I. The interest is calculated immediately before each payment for this loan, and the repayments are made. Now, they want us to work this out. So really what we want to know, if you look down here, these are the PPY is the question. How often are we compounding this? So what I can do is I've written out the formula of how interest is calculated. So how this amount, say, was calculated. So I could write 900 equals the rate per annum, which I know is 3.6. PPY is what I want to know. So I'm just going to call it X. Okay, and over 100. And we know we find the interest by timesing that rate by the balance before. So I do 300,000. When we get something like this with just one unknown, we can pop it in our solve function and comma X. And you'll see that X equals 12. So that means PPY is 12, which means it is monthly. Okay, so in this graph, question, they've asked us that we're looking at a compound interest investment. So with a compound interest investment, you're always timesing the balance before by a rate, a certain rate to get the next bit. Okay, so which is often, we could say, and the rate is, we can find it. It's the rate 1 plus the per annum rate over PPY over 100. But you can think of this as like a whole rate section. So if you have a look, we need to find the value at this third spot. So really the way we get the next one in a sequence is that how we got 500 is 500 from 500 to 580. We times 500 by this rate as such, which was 1 plus. Okay, so if we can work out that rate, we can times the 580 by that rate. Okay, so what I'm going to use is I'm going to use these numbers here and use like the formula to find it. Okay, so what I'm going to say is I found 580 by timesing the rate by the one before. So I'm just going to say 500. So if I just put that in to solve, comma R, I'll get a rate. So I'll do that. So I get 1.16. Okay, so therefore I can get the next one, that B, by going 580 times the 1.16 to get the 672.80. Okay, a machine is purchased for 30,000. It produces 24,000 items per year. So just remember that's each year. So if the usage, so the value of the machine depreciates using unit cost method. So once you see this unit cost, I want you to go have handy your unit cost formula on your finance summary sheet. And after 3 years, the value of the machine is this. A rule for the value of the machine in units produced VN is, so here you can see we've got the VN rule there. So if I go and copy that out, so VN equals VO. So it was purchased for 30,000. So I can pop that in, and it says minus N. Now because the D is in pink, that means you need to work out the D. And I've got the formula there on how to work it out. So D equals the amount depreciated per period. So if you think it's gone from 30,000 down to 18,480. So if you do that, that will tell you how much it's depreciated. And then the number of uses, well, it's had 24,000 uses every year and it's been 3 years. So when you work that out, you end up with 0.16. So if I put that back in the formula, you can see how I get this answer, 30,000 minus 0.16 times N. Okay, looking at question 23, Joseph borrows 50,000, so it's a positive PV, to buy a new car. The interest on this loan is charged at a rate of 7.5% per annum. So in Finance Solver, that's the I, and compounding monthly, PPY is 12. Joseph will fully repay the loan in 60 months. So that's N would be 60, and 60 monthly payments over 5 years. So 5 years is actually, if you do 12 times 5, it's 60. So they've pretty much already said that. Immediately after the 59th payment, Joseph he still owes 995.49. So what is the final payment to the nearest cent? So what I would like you always to do is you should always, well, first of all, is you want to see what the payments are, the final payment. So because we don't even know what the payments are. So if we go through Finance Solver and we find that first. So we go N is 60, I is 7.5, PV, a positive. Payment's going to be the question. FE, so if he was paying this loan off, it would be 0, and PPY is 12. So we get that the payments are actually, he's paying $1,001.90. Okay, so we get that. So now we want to know his last payment is going to be adjusted, which is very common in a loan like this. So what I always want you to do is just always go and see what's happening at the end of the loan. So I'm going to the end and I'm going to query what the actual final value is at the end of this loan. And I needed to find the payments, which I now have. So I've popped in all the data, and at the end of the loan, the 60 payments, we've got here that it's 0.1, and I'm just going to round to the nearest 19. So what's that mean is that because this is a positive number, a positive FV, that means the bank owes you. So I would, his last payment doesn't need to be this full 1,000. His last payment can be the 1,001.9. Well, the bank owes him 19 cents. So I'll minus that 19 cents from the last payment, and that's how we get this answer here. If it was negative, you'd have to add it to the payment. So just be careful with that. And what you need to know, why do we go to the end? Don't go to 59, go to the end, because you're always got to put interest on even in the last month. So you might get confused if you don't do that. If you've got to make sure that interest is charged in the last payment. So always just go to the end. If it's positive, the bank owes you. If it's negative, you owe bank. Okay, so you would add that to your payment. Okay, Millie invested 20,000 in an account at her bank with an interest compounding monthly. So if you're investing, PV is negative, compounding monthly, PPY is 12. After 1 year, so I like to write what the N would be, that would be 12 months, the balance of Millie's account was that. So they were 20,732. So that's what the bank has to give her back. So that's a positive FV. The difference between the interest rate per annum, so remember that is I in Finance Solver, and the effective annual rate. So when we do effective interest rate, we actually do I, comma, the PPY. So the rate per annum, comma, pi. So they want the difference. So we've got to be really careful and look at what they want. They want the difference between this I and the effective interest rate. So we've got to go out and find what that is. So we probably need to find I, because if you look through what we've been given, we were given a 12-month status, so we did that, pop that in there. I was what I needed to know. PV, I could pop in. The payments, there was no mention of it, so we just put 0. And the final value we can pop at the end of the 12 months is there, and we're making sure that's a positive. Okay, and PPY is 12, and we get this interest rate. So the rate per annum is actually, I'm just going to round, 3.6%. So this is the per annum rate. So I've popped that now into the effective formula where we just type EFF. And if I round that to 2 decimal places, I get 66 is the effective interest. So the difference between 3.66 and 3.6 is 0.06. So there's how we got that percentage. Okay, so with these ones where they're talking about the element in row I and column J. So what they call is, when they want to talk about the row number, they're talking about I. So if I is 1, the number is in row 1. If I is 2, the number you're wanting to go for is in row 2. And then J is indicating the column. Okay, so with these ones, unfortunately, you just sort of got a trial and error. And they'll get annoying, and hence people don't want to do them. I think that's why they're not performed as well. So what we're going to do is we probably always try to remember you should probably test 2 numbers. So I'm just going to test those 2 with the formula. So if you look here, if I was trying to find this element, this spot here, using the first formula, it'd be 4 minus the J at that spot. Now the J is 1, so 4 minus 1, it does equal 3. So that works. So what about if I try this spot? So what that would be, it's actually row 2, column 2. So if I was using the formula, it'd be 4 minus 2, because J is 2 in that one, which equals 2. So that's not, so I can rule that out because it's not the answer. It's actually a 4 there. So I get rid of that one. I then go again. So I'm trying that first spot where it's in 1, 1. So it's saying to do 2 times I, which would be 2 times 1 plus 1. So that equals 3. So if I try my other position, which is 2, 2, it'd be 2 times I, which is in row 2, plus 1. So that equals 5. So that one doesn't work either. All right, so I try again. In this one saying add the row and the column and add 1. So that does equal 3. So you can see the first one equals 3. It works for a lot. So that's why we need to test 2. So in this one, we're doing 2 times 2 because it's in, sorry, take that back. We're adding them. So we're doing row 2 plus column 2 plus 1, and that equals 5. And that one doesn't work either. Last one, 1, 1. We'd have I, row 1, plus 2 times the column, which is also 1. So that does equal 3. But if we do it with the 2, 2, it's row 2 plus 2 times the column, which would be 4 plus that, it'd be 6. So that one doesn't work. So if you test this last one, it will work. Okay, so let's go with that answer. Okay, question 4. Stella completed a multiple choice test that had 10 questions. Each question has a possible answers, A, B, C. For question number 1, Stella chooses E. So you know that E is her first answer. So if you think, and it says Stella can choose each of the 9 remaining answers in order. By following this transition, what answer did she choose for her 6th question? So I've just written out here the 1, 2, 3, 4, 5, 6. So I know. Now, she's chose E for question 1. So what you're saying is you're at this question at the moment and you're at E. So if you go down E, where there's a 1, that means that's what you're answering for the next question. So you're at C. So now you do the same thing as I just did before, but you now say, this question, I'm at C, and I go down and it's on A. So I write A. And I go again. I'm now at this question, I'm now on A. So I go down and I get D. So now I'm at D. So this question, I'm at D. So I will go down and I'm now at B. We're now at B. And now we go down and in this question, we're at E. So this is how I got E for the 6th question. Okay, a water park is open from 9 a.m. to 5 p.m. There are 3 activities, pool, slide and water jets at the park. Children have found to change their activity at the water park each half an hour as shown in the transition below. So here they've got this transition showing. A group of children has come to the water park for the whole day. The percentage of children who are expected to be at the slide at closing time is closest to. So they want a percentage. So when we're using a transition matrix, we actually need a state matrix. So say a SO. So because they want a percentage, I'm going to actually put 100% at one spot and put the rest in there. You could break it up. Now, if I looked at 9 a.m. to 5 p.m., that's 8 hours. So there's 16 30-minute slots because of 8 hours. So what I did first is I thought, all right, I'll raise this because this is all we can do. I'll raise this to 16 and here's my state matrix and I got the following percentages. Now, because there was no other information of how they started the day, just to make sure, I decided that to have a look at if I made it a big number, like long term, because you never know. 16, you probably could hit the long term scenario. So if I've raised it to 50, which would be long term or the steady state, you saw that you get the same percentages. So I'm quite happy in saying, so it doesn't really matter that I put everyone at the start, because remember when I said when you do the long term, it will pan out. It doesn't matter how you put them in the start, they will pan out to this end state. So they've asked, this is pool, slide and water, jets or something, water jets, the percentage of people at the slide. So this is this number, is closest to, so we're going to say 14% for this answer. Okay, the communication matrix below shows the direct paths by which messages can be sent between two people in the group U to Z. So when they said the communication and direct path, this is one-step communication. So we often just called it the C, okay? And one just means, and they will always write this, they're just telling you one means they can communicate. And who with. So how many ways can Y get a message to W by sending it directly to one other person? So we want to go from Y and we want to go out to someone else, and then that leads to W. So if we just go and have a look, so we're at Y, and look who Y can send a message to. Y can send a message, looked on the wrong thing. So Y is on the sender here. And who can Y send a message to? Y can send a message to W, X, and Z. Okay, so Y can send it to W, X, and Z. Now they wanted a message by sending it directly to one other person. So we don't want to go directly to W. So then we've got X and Z. Now, what we want to look at is, can X and Z go to W? So if you look along here, no, X can't. If I look along Z, Z can't go to W either. So I'm going to say there's no one who could do it it's pretty much a two-step communication when they say directly from one person to another. This is saying two steps. So no one can. Okay, an airline parks all of its planes at Sydney Airport or Melbourne Airport overnight. The transition diagram below shows the change of locations from night to night. There are always M planes parked at Melbourne Airport and always S planes parked at Sydney Airport. So what that means is their numbers are always the same. If there was 100 at Melbourne one night, there will be 100 at Melbourne the next night. So if some go out, then the same amount must come in. So of the planes that parked at Melbourne Airport on Tuesday night, 12 had been parked at Sydney Airport on Monday night. So that's the night before. So if you look, they were at Sydney and they went to Melbourne, and we're saying that there was 12. So if I call Sydney, they said the amount of cars at Sydney was Sydney and Melbourne. So what I know here is when I go Sydney times 0.48 equaled 12. Okay, so you can solve that in your calculator if you like, and you get that S equals 25. Okay, but what we're saying, because remember as before I said they had to say, so if I had 12 going into Melbourne, because they always stay the same number, that means 12 needed to go out. So I can say that M times 0.2 has to equal 12 as well. So we do that and we can do the solve like we did here. Now they said how many planes does this airline have? So we needed to add them together. So we get 85 here.